Hi everyone, today I'm going to talk about how to use Solver to achieve labor optimization. In a lot of company, managers try to achieve best workforce scheduling and minimize labor costs. It is very common for companies to hire both full-time and part-time workers. Part-time workers can provide more flexibility in time and lower labor costs. So I'm going to talk about labor optimization for a new bank. The bank hired both full-time and part-time workers to cover work schedule. The management team of the bank gives an estimation of the teller needed in each hour. Now let's take a look at the first Excel sheet. So the data table shows the number of tellers needed for each hour. The number of tellers needed for each hour is different because in certain time period there will be more customers coming to the bank for services. On the right side, the chart shows the number of tellers required in each period. As we can see, the peak hour is from 1 p.m. to 2 p.m. Now let's move on to the next Excel sheet. In the right-hand side of the Excel sheet, FTS stands for full-time shift, which is from 9 a.m. to 5 p.m. And there are 5 available part-time shifts, each cover 4 hours. For example, PTS1 cover from 9 a.m. to 1 p.m. Now let's take a look at the left side. So in column 1, I list out all the work hour slots, 1 hour per slot. Then I list out the possible teller from each part-time shift to cover each hour period. In fact, every hour slot has the full-time shift because the working hour for the full-time teller is from 9 a.m. to 5 p.m. Then we see that PTS1 appear in all 4 slots from 9 a.m. to 10 a.m., 10 a.m. to 11 a.m., 11 a.m. to 12 a.m., 12 p.m., 12 p.m. to 1 p.m. For example, if we look at the time slot from 10 a.m. to 11 a.m., we need at least 7 tellers in total to cover the whole shift, but the number of full-time and part-time is unknown. So our goal is to figure out the specific number of tellers the bank needs to hire in order to cover the work slot. And at the same time, the management team wants to minimize the labor costs by finding the optimal number of full-time and part-time tellers. Now, let's go to sheet 3. So in sheet 3, I set up Solver to find the optimal number of tellers for the bank to minimize the cost. So in column B, it shows the cost of each full-time teller per hour. And the cost for full-time teller per day, as we can see from the formula, is the number of full-time teller multiplied by 18 and multiplied by 8 hours. On the other hand, the cost per hour for the part-time is only $10. And the cost would be the number of part-time teller multiplied by $10 and multiplied by 4. And when we add up all the costs, we got the labor cost per day. So the cell E9 is our objective cell. Cell C3 to C8 represent the number of full-time and part-time tellers to hire for each shift, which are the changing variable cells. And the banks require at least 10 full-time tellers to be hired, so that should be one of the constraints. The other constraint in this problem is the number of tellers need to hire should be equal or greater than the minimum number of required tellers to cover each work slot. So it's this part. Now, when I click Solver, we can see that our goal is to minimize cell E9, total labor cost per day. The changing variables are C3 to CA. And the first constraint is C12 to C19 should be equal or greater than E12 to E19. The second constraint is C3, number of full-time tellers should be equal to 10. The last constraint is all C3 to CA should be integer. And then I click solver to get the result. So these here are the result I get from solving this situation. For example, C6 shows the bank need to hire at least 8 part-time tellers to cover PTS3, which is from 11 a.m. to 3 p.m. C10 is the total number of tellers we need to hire, which is 40. And here, 2,640 is the total cost of labor per day. Now, let's take a look at how many tellers will be covering each hour's log, which is shown in C12 to C19. In C12, it shows there will be total of 12 tellers include both full-time and part-time, serving customers from 9 a.m. to 10 a.m. As we can see, the formula is C3 plus C4, which is the number of full-time shifts plus part-time shift. If we go back to the previous Excel sheet, we can see that in 9 a.m. to 10 a.m., it shows that the banks need full-time shift and PTS1, which is part-time shift 1, to cover the required number of tellers. However, in C14 shows the number of tellers need from 11 a.m. to 12 p.m. is 32, which is greater than the minimum requirement of teller. So due to the scheduling, in this hour slot, the bank will have more than enough teller serving customers. The next Excel sheet is very similar to the one I just talked about. The only thing I changed for this example is the required number of full-time. So in situation 1, the bank required at least 10 full-time. So I want to show what if the bank changed its policy and required at least 15 full-time. So when I go to the solver, we can see that I changed one of the constraints, C3 equal to 15, and everything else stayed the same, just like the first one. Then I solved to get the result. As we can see, we got totally different number of tellers compared to situation 1. And then we see the total teller we need to hire is 35. And the total cost per day would be 2,960. Finally, when we go to the summary sheet, here I list out the summary of costs for both situation 1 and 2. Due to the change in the number of full-time, the bank will have a completely different labor cost and number of tellers to be hired. From the result I get, I suggest the bank to keep its current policy to hire 10 full-time workers. As we can see, the cost would be smaller if they maintain the 10 full-time requirement compared to the second one with the higher cost, because the full-time usually costs the company more in labor costs. So here's the end of my video. Thank you guys for watching and hope you guys like it.